Hi everyone, welcome to Science Lab. The science are happening because Lord Jesus Christ is coming again very soon. Every day we are looking at some of the signs that are happening around us.
And in this episode, we are going to see about the strange things that is happening in the sky.
Since ancient times, we have asked what lies over the horizon and beyond the oceans. Where does the world end? And we pushed further and further out the journey has revealed a solar system, a galaxy, a universe on large and larger scales.
And now a new set of theories is telling us that time and space are incomprehensibly large. What will we learn on search for the age of the universe?
If you could step away from our world, what would you see? How do deserts fit in with oceans or mountains with floodplains? What structures connect the Earth to the other planets, the stars, and beyond?
The ancient Greek philosopher Aristotle believed Earth lay at the center of the series of 55 celestial spheres, with each moving in a way that predicted the positions of the planet or the stars within them. He saw these our outer realm as house of the gods. He said, "These are made of a pure substance not found on Earth."
The Greeks were also the first to see celestial events as natural phenomena subject to human investigation. One sky watcher named Anaxagoras suggested that meteors are made of materials found on Earth and might have actually come from the Earth. He and other Greek astronomers helped build the foundation of science, but they would be shocked to see the discoveries being made by their counterparts today. The stars and planets that once harbored the gods are now seen as infinitesimal parts of vast scaffolding of matter and energy that extend far out into space. Aristotle's model of a cosmos centered on the Earth lasted until the 16th century. Nicholas Copernicus proposed the Earth and other planets instead revolve around the Sun. Based on his findings that planets have their own orbits, scientists constructed new models that describe their movements over time. Copernicus noted too that the firmament, the stars, lay far, far beyond the solar system. Our model of the universe began to get much larger in the year 1609, when the scientist Galileo Galilei used the first astronomical telescope. He observed that the Milky Way, a broad band of the light that rises up in summer skies, is actually composed of stars. Centuries later, astronomers discovered that the Milky Way is actually a vast revolving disk. They characterized the universe as an island of stars and gas, immense yet still limited in size. This model of an island universe would soon collapse under the weight of scientific evidence. Working with a huge new 100-inch telescope on California Mount Wilson, astronomer Edwin Hubble and an assistant named Milton Mason analyzed the light of fuzzy patches of sky known as the nebulae. They found that these patches were actually galaxies unto themselves, but located far beyond our own. They also found that many of these galaxies are moving away from us. The farther away they are, faster they are receding. In an age of atomic weapons and nuclear physics, a whole new model of the universe emerged, a dynamic realm shaped by giant exploding stars, shock waves, and black holes. In this view, the universe had its origin in a violent primordial event, a Big Bang. The Big Bang model rested on four main pillars: that the universe as a whole is expanding in all directions. If you turn the clock back, you'd see that all matter and energy had a common starting point in space and time. The existence of light elements like hydrogen, which would have formed in very early times and later converted to heavier elements. That there is light wafting through the universe that was emitted when the universe was young and stretched out over time into microwaves. Finally, it established a time frame for the evolution of stars, galaxies, and the large-scale structures of the universe. But But this new model of a Big Bang universe proved incomplete. Recent precision measurements gathered by the Hubble Space Telescope and other instruments have brought a consensus that the universe dates back 13.7 billion years. Taking cosmic expansion into account, galaxies at the edge of the visible universe are actually 46 billion light years away from us in each direction. What's beyond those galaxies? They have their own horizons that extend that much farther out. What's beyond them? Where does it all end? And how did the universe grow to such an immense size? Another observation puzzles astronomers no matter what part of the sky you examine. The spread of galaxies, the density of matter, and the temperature are the same on large scales. To achieve this degree of homogeneity over its entire breadth, the universe would have to expand it far faster and to great extent than allowed by the standard Big Bang model.
In the beginning, when God opened his mouth, he spoke out the word, everything was created like a big bang. Without understanding it, scientists are saying that everything came into existence all of a sudden and they call it a Big Bang theory. Actually, it is God who spoke it and it all happened.
So far, we saw some of the strange signs that are taking place in the sky. Don't go anywhere, let's meet after a short break. Welcome back to Science Lab. The signs are happening because Lord Jesus Christ is coming again very soon. Before the break, we saw some of the strange signs that are taking place in the sky. Now let's continue. Throughout the ages, the number of planets in our solar system has gone up and down. Now, this is not because planets have suddenly appeared or disappeared, but rather due to how were they discovered.
Since antiquity, there were 5 planets beyond Earth, which are the ones visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. The ancient Greeks added the Sun and the Moon to the list of the planets, but the idea never really caught on.
The universe is big, that much is certain. But it's easy to lose perspective of the object and distance at work when they reach a certain size because there's really nothing to compare them to. And yet, for a long time now, humanity has been trying in some way to measure its reality. Today, we are answering the extraordinary question, what is the true scale of the universe? The first hurdle in measuring the universe is the measurement themselves. Determining the size of anything in outer space is difficult because there are so many metrics in play. You could measure the mass of something, the volume, the diameter, and each would give different results. Black holes, for example, are massive, but usually don't have large diameters relative to that mass. The supermassive black hole at the center of the Milky Way, Sagittarius A star, has a diameter around 30 to 40 times that of our Sun, which is big, but it is also much smaller than other larger stars. Stars, by contrast, can have much less mass but still spread across a vast area, making them appear far larger. We are primarily working for the diameter of celestial objects as the best metric to determine their size. Planet Earth is the largest of the 4 inner planets in our solar system, though its diameter is only around 400 miles more than Venus's, which is sometimes called Earth's evil twin. Mars and Mercury are both much smaller, with Mercury being only twice Pluto, keeping in mind that Pluto's small size was one of the reasons that it was recognized as a dwarf planet in 2006. Mars is 4,212 miles across, more than 3,700 miles smaller than Earth. But the Moon can actually hold its own here, being nearly 2,200 miles in diameter and therefore also larger than Pluto. But bizarrely, just the area taken up by the Pacific Ocean on Earth is still wide enough that the entire Moon could comfortably fit inside it. In terms of distances, the Moon is obviously the closest thing to us, but even it is 238,855 miles away. If the Earth were the size of a tennis ball, the Moon would sit roughly 7 feet away from it. The biggest planet in our solar system are the gas giants, and the biggest by far is Jupiter, which has a diameter of almost 87,000 miles, meaning Earth could fit inside it more than 1,300 times over. While the gas giants are huge, however, they also have very low densities, leading to the popular assertion that if you had a body of water vast enough to hold Saturn, it could float. Really, though, it is not uncommon for gaseous planets to balloon to such incredible sizes. More interesting are exceptionally large rocky worlds. Leading candidates as the largest known planets to this type include Kepler 10c, discovered in 2011 with 17 times more mass than Earth, and the catchily named BD plus 20 594p, discovered in 2016 and thought to have a diameter more than double Earth's. Places like these are so big that they are officially classified as mega-Earths, but planets certainly aren't the biggest objects in the universe, not by a long shot. Stars are generally the largest singular objects. Our Sun is by far the largest thing in the solar system, but it's still not that big compared to others. The largest star we ever found is UY-Scuti, which boasts a diameter 1,700 times larger than the Sun's, despite being only 30 times more massive. The brightest star in our sky apart from the Sun obviously is Sirius, otherwise known as the dog star. The heaviest star is neither UY-Scuti or Sirius, though it is a blue dwarf currently christened R136A1, which has 315 times the mass of the Sun. But let's zoom out further. Galaxies made up of billions and billions of stars and planets combined are among the biggest structures in the universe. Our own Milky Way is thought to be an average-sized galaxy with an estimated diameter of at least 100,000 light-years. So far, we have only found a few thousand star systems in the Milky Way, but scientists predict that there could be billions more that we have yet to locate, and that's just in our galaxy alone. Working mostly with the data on the Hubble telescope, astronomers have estimated that there are between 100 to 200 billion galaxies in the observable universe. The smallest of those are thought to be just 3,000 light-years across, while the largest are over 300,000 light-years across. The closest other galaxy to us is Andromeda, which is over 2.5 million light-years away. The real interesting part, scientists say, is roughly 4.5 billion years, when the Earth is twice as old as it is now. Andromeda and the Milky Way are set to collide and blend into one giant galaxy, something which some scientists are already calling Milkodromeda. In reality, though, it is unlikely that we will ever see these distant planets, stars, or galaxies up close simply because of the unfathomably huge distance between anything in outer space. Humans haven't ever been to another planet in the solar system yet, but the solar system is really quite small in the grand cosmic scheme of things, with a radius from the Sun of around 1.87 light-years and a light-year equating to around 5.88 trillion miles. That means it takes nearly 2 years for even light to travel out of just our star system. In general, though the solar system is too small to practically measure it in light years, instead we use astronomical units, with 1 AU the equivalent to the average distance between the Earth and the Sun, roughly 93 million miles. The distance from the Sun to the outermost edge of the solar system is 100,000 AU, but the next closest star to us is Proxima Centauri, is more than double the distance of over 268,000 AU or 4.2 light-years away. In 2015, the New Horizons probe reached Pluto after a journey of more than 9 years. Say we continued at that speed, we'd reach Proxima Centauri in around 58,000 years' time. So we need 1/6 of the whole of human history to make just a one-way trip to the closest star system of our own billions of star systems in the entire universe. But what's even crazier is that all of these objects, the planets, moons, stars and galaxies, are only what we see in the observable universe. The true universe is so huge that the light from the Big Bang hasn't yet reached every corner of it, despite traveling for close to 14 billion years. According to a 2011 study conducted by a team at Oxford University, the universe could even be as much as 250 times bigger than what we can currently see, which puts it at 7 trillion light-years across. But because of cosmic expansion, if those 7 trillion light-years were ever observed by the time the light had reached that far, the universe may have grown to be even bigger. And finally, when you consider that only 5% of everything is all that we can see and comprehend, the rest being dark energy and dark matter, then the staggering entity we are dealing with truly makes it known. Space is larger than we can possibly comprehend, but it's still getting bigger and bigger, and that's the true scale of the universe.
This idea amounts to a quantum leap in our sense of scale. By extending our ideas to the structure of time and space far, far beyond our visible horizon, does it push us on our tiny out-of-the-way planet into a smaller and smaller corner of creation? Or does our ability to assemble models that describe the larger universe somehow elevate our importance in the grand scheme of things?
Once upon a time, people thought that Earth is the center of the universe and everything, including the sun, moon, and stars, evolve around it. Later, they found the truth about the solar system and beyond. In these last days, every secret about the Earth, the universe is getting wide open. Do you know why the knowledge is exploding? Daniel chapter 12 verse 4 says, "Many shall run to and fro, and knowledge shall increase."
All this shows that what is mentioned in the Bible that are going to take place in the end times are taking place in our lifetime. We are living in the last days and the Lord Jesus Christ is coming again very soon. Thank you for watching this episode and don't forget to tune into the Science Lab next time.
Before we end the show, we would like to ask you a question from this episode. How many planets are there in our solar system? Option A, 8 planets, option B, 9 planets, and option C, 10 planets.
And if you know the correct answer, send it to our email ID sciencelab@angeltv.org. If you have missed any of the episodes, don't worry. You can watch it again and again in our Science Lab YouTube page. But don't forget to like, share, and comment on the video.
Ask your friends and relatives to watch Science Lab so that they will know that we are living in last days. Remember, signs are happening because Lord Jesus Christ is coming again very soon.
Maranatha.